All right, so moving on to the nephrons. These are the tiny little structures that actually do the filtering. A kidney, so each kidney contains approximately 1,000,000 nephrons. So your kidneys are full of these tiny little structures. Each one is going to have a renal corpuscle and a renal tubule, and we will look at that. The renal corpuscle is the filtering portion. You should know that. Renal corpuscle is the filtering part of your nephron. It's made up of a ball of capillaries, and that ball of capillaries is called the glomerulus, and a glomerular capsule that then is going to receive or catch the filtrate. So what's been filtered is going to enter that capsule. Renal tubule leads away from the glomerular capsule and first becomes, it's highly coiled, it's called proximal convoluted tubule that leads to the nephron loop. The nephron loop is basically a bunch of ascending and descending limbs, and then finally it's going to go to the distal convoluted tubule. So proximal, it's closer to the nephron. Distal is going to be further away. Several distal convoluted tubules then join and become the collecting duct, which passes into the medulla part of your kidney, and then it empties into a minor calyx at the papilla. So here is looking at a picture. So if I have my kidney here, here's that medulla part, here's the darker brown part is going to be here. The renal cortex is where most of the parts of your nephron are at. Basically, when you get down into the medulla, you're going to have your nephron loop that comes down, so descending it comes down and ascending it comes back up. This is your collecting duct, so this is going to be the larger collecting duct where things start to come together. So if I look at, this would be a glomerulus, so here's where your capillaries are surrounding a nephron. There are going to be proximal convoluted tubules that are going to be close to this nephron, and then the distal convoluted tubule is just closer to this collecting duct. So basically, it almost looks like you have a messed up ball of yarn or something like that. There's tons and tons of little tubes, and the function is, here's all these arteries, here's all these blood vessels, period, where that filtering is going to take place. So once it's filtered in this nephron, it goes through a series of tubules and then actually eventually ends up draining through this collective duct. I like this diagram. It kind of gives you basically top to bottom where things go through. So the nephron is surrounded by this glomerulus. So this is where the filtering actually takes place. Then the capsule is the part that surrounds it. Convoluted tubule, proximal is closest, so that's going to be first. That nephron loop drops down, comes back up. Distal convoluted tubule is going to lead to your collecting duct. So here basically is where the filtering takes place, and that filtering is what forms urine. Once that urine is actually collected, then this is going to be the series that it goes through to get rid of it. So once it's in this collecting duct, it's going to go through the minor calyx, major calyx, into the renal pelvis, which drains into your ureter, down to the bladder, and then out of the urethra. So I do like that figure to look at to kind of wrap everything up. Blood supply, obviously nephrons are a working structure, so they need a blood supply themselves. The glomerulus that surrounds the nephron receives blood from that afferent arteriole, we talked about that, and then it passes it. A bit smaller arteriole is the efferent arteriole. So these actually supply blood to your nephrons. The efferent arteriole gives rise to the paratubular capillary system, which is going to surround the entire renal tubule. And then the blood enters the venous system of the kidney and will eventually leave through the renal vein. So here, what we've kind of done is spread these loops out so it doesn't look quite so twisted. So here is basically my nephron is inside of here. The glomerulus is what surrounds it. Here's the capsule that encloses it. Afferent blood comes in. Efferent is going to lead out and be carried away. And if I stretch this tube out, proximal convoluted tube leaves the nephron or leaves the glomerulus, and then it goes through this loop, it comes down, it comes up, and then it's going to go through the distal tubule. So basically, this is wrapped up, this is wrapped up, we've just taken it and spread it out, so you can actually see the order that it goes through. The juxtaglomerular apparatus, the point of contact between the afferent and efferent arterioles and the distal convoluted tube, the epithelial cells form what's called the macula densa. It's a dense area. Near that area on the afferent arteriole are smooth muscle cells, and those smooth muscle cells are called juxtaglomerular cells. So basically, when I get this area together, it's called the juxtaglomerular apparatus. So this is going to include the smooth muscle cells, and this is basically the epithelial cells. So macula densa are epithelial cells. Juxtaglomerular cells are smooth muscle cells. And so here you can kind of see down here where that would be. These juxtaglomerular cells are going to surround these arterioles and basically help to squeeze those arterioles. And then there's a layer of epithelial cells right on the outside of those smooth muscle cells. And that's where we'll stop for today.